Today I'm going to be talking about the possible mutations that can happen within a DNA sequence that change the outcome of the amino acids that code for a protein. In a DNA strand, there's a coding and a template strand. The template strand is what the RNA polymerase binds to and makes a corresponding mRNA strand from. The coding strand is a mirror image of the mRNA strand but contains thymines instead of uracils. This transition from DNA to RNA is called transcription. Then, from RNA to making the amino acids for the protein, this is translation. You can think of this as building a house. An architect has the image of what he wants the house to look like in his head, but the construction workers can't see inside his head, so he must make a blueprint. This is changing the DNA to RNA. When the blueprints are ready, the construction workers use the blueprints to build the house correctly, much like how ribosomes read the RNA strand and code for the correct amino acids. However, sometimes there are mutations, either frameshift or point. In this one, we're going to look at 4 point mutations. These are going to be readthrough, nonsense, missense, and silent. The mutations occur whenever one of the bases is changed from what was originally in the DNA sequence. If the bases that are changed stay within the same group, this is a transition. So for example, if a T is changed to a C, these are both pyrimidines, so this is a transition. But if it was to be between a C and a G, since these are not the same category, a purine and a pyrimidine, this is a transversion. We're going to first look at read-through. In this example, a T is changed to a C, so this is a transition, and you can see that the read-through, the codon for stop, is changed. This causes the amino acid chain to lengthen. In building a house, you can think of this as the weather not going according to plan and the finish date being pushed back. This is because it does not stop at where it was supposed to stop, just like read-through. The second example is a nonsense. This is where the stop codon is placed before where it originally was. In this example, a is changed to a T, and so the codon is earlier than it was previously. In building a house, you can think of this as getting extra workers so that the finish date is sooner. In missense mutation, the changing of one base changes what amino acid is coded for. So in this example, a C is changed to a G, and this changes the amino acid that the codon codes for. In building, you can think of this as if you needed to change the window dimension. This could completely change what the outside of the house looks like. The last type of mutation is silent mutation. This is where the coding strand has a different base, but the amino acids that are coded for at the end are the same. You can think of this as the wrong wood being delivered to build the house. The wood is still structurally sound, so it can still be used, but it's not what originally was there. Likely, you won't even notice the difference, which is why it is called silent. So to recoup, in transcription, if there's no mutations in the DNA, the blueprints will go on smoothly and the crew will be able to build the house in adequate time. If there's a read-through mutation, the time that the house needs to be built may take a little longer, but if there's a nonsense mutation, it may be a little shorter, but the house could possibly not be done correctly. In missense mutation, this means that the house might not look the exact same because something was changed. In a silent mutation, it's likely you won't even recognize what's being changed.